So number 6, this is kind of a tricky one, and you just have to think outside the box, I guess is the best way to explain. Don't fall for the traps, though. Try not to. I just went ahead and took the liberty of putting some points over here, -1, 4, and 3, -2. It says we have a relative maximum at -1, 4. It also says that the function is continuous, and that's all that it says. That should be your first clue that it doesn't have to be differentiable. Okay, so that you don't fall into this trap. If we did, let's say, relative maximum nice and smooth there, and then a relative minimum nice and smooth there, it might look like at first glance that A is possible, that you have to have a point of inflection somewhere in between. Well, you would if the graph looked like that. If it was nice and if it were differentiable, then yes, you would definitely have to have that, but it doesn't say that. So I'm a little sketchy on part A because that's my first choice, and that would be another sucker answer. If I'm not really thinking clearly here, I'm going to go for that. F prime at -1 is 0. Okay, well, if this were the case, then both of these would be true. F prime at -1 would be 0. Both A and B would be true. So now I'm thinking there's no way that this could look like this because, again, both of them would be true. And so what else would be true? I'm going to throw out B, but the graph of F has a horizontal asymptote. Well, that's definitely not true because of the graph I drew. That doesn't even fit that. The graph of F has a horizontal tangent line at x equals 3. So that's just like B. So B and D, if the graph looked like this, it would be those would both be true. So I'm thinking no way it's going to be D as well. The graph of F intersects both axes. Okay, well, let's see here. Intersects both axes. So it's definitely going to intersect the y-axis. It has to intersect the y-axis because it's continuous for all x. Okay, so it has to go through the y-axis. But then does it have to go through the x-axis? Well, it sure does here. Continuous, but what's the reason why it's not A, B, or D? Well, I'm going to show you. Okay, what if I drew a function that was not differentiable over the entire domain, but it met still the criteria that you had a max here at -1, 4 and a min here at 3, -2. So this certainly does, but there is no inflection point. Okay, there is no f prime of 1 equaling 0, and there's no horizontal tangent line at x equals 3 either. And so this graph does intersect both axes. It has to be continuous, and that the intermediate value theorem would guarantee. Yeah, I'm not quite sure what I had just said. Just got a phone call, so time back in. But I have the answer here. We've got. I don't think that there's anything else to really talk about, but if there is, let me know.